Okay, goeiedag julle. Ek hoop julle almal is gereed vir vanmiddag. Baie dankie dat julle hier is. Ons waardeer dit verskriklik baie. My naam is Johan Koekemer, die hoof van die Vereniging van Afrikaanse Wiskundeonderwysers. En ja, ek is verskriklik opgewonde. Ek dink as jy net een persoon opgedaag het op 'n middag, donderdagmiddag, was dit vir my eintlik al klaar dat my verwagtinge oortref. So julle is fantasties. So dankie daarvoor, maar ek vra mooi om asseblief hierdie te deel met jou vriende, met jou kollegas, sodat ons op die einde van die dag soveel as moontlik mense kan bereik. Ons groot visie en missie is die instandhou en onderhou en nuutbou van Afrikaanse skole, en ons het verskillende toertjies wat ons doen om dit te verseker. Dan wil ek ook net noem, julle kan vir julleself 'n sertifikaat kry vir die opleiding met jy 'n VAW lid is. Daai sertifikaat kry jy deur op die portaal te gaan. Aan die einde van hierdie opleiding kan jy op die portaal gaan onder events en daar gaan registreer vir die Polypad. Ek het getik Polylab vir die Polypad werkwinkel graad 4 tot 7 en dan sal ek so ook jou aktiveer en dan kry jy jou sertifikaat gratis wat wys dat jy het hier die professionele ontwikkeling bygewoon. So nou gaan ek oorskakel na Engels. So that David also can present. David, thank you very much for joining us. We really do appreciate this. English is our second language and majority of us only speak it in self-defense if we really need to. So if I slip up and give some S's where they're supposed to be R's, please forgive me. But I do think that we will not only learn from you about maths, but also maybe some proper English. We'll hear that. So thank you for having us, for being here. We are having you. And thank you for making time in your schedule. And you just did it out of free will. Our teachers really do appreciate it. And I think that a lot of them are going to use, especially Polypad. And yes, from my side, just thank you. Thank you for being here. I'm going to give it over to you now. You have the steering wheel. Please inspire us for the next 45 minutes.
Thank you so much for having me. It is a pleasure to be here. I'm not sure my English will be all that proper, so I don't know how much I'll teach you about English, but I will try to speak slowly. I have a habit of speaking fast in these presentations where I have so much to get through in a short period of time. I have so many exciting things that I want to share with you. It's a pleasure to speak to educators from South Africa. I was sharing at the beginning, I had the pleasure to travel to South Africa many years ago, and what a beautiful country full of even more beautiful people. Everyone was so welcoming and kind, and it's just a real pleasure to be with. So I appreciate all the welcome in the chat, and it's a pleasure to be with you and doing some math today. I've put a link in the chat to a Google Doc that has a number of links that I'll be sharing with you today. I know this session is going to be recorded. If you want to hit record when you're ready, that would be great. So you don't have to take it all in as you're doing it. You can go back later and do it. I'll hit record on my end. I think I might be the host now, so I have to hit record, right?
It's recorded.
It's already recording. Great. Awesome. Great. So I am a math teacher. I teach 6th and 7th grade math as my full-time job in Boston, Massachusetts, in the United States. About a year ago, I was looking for a additional online place for enrichment for my students, and I stumbled across Mathagon. This is about a year ago now, and was really impressed and excited to begin to use their tools. I saw that they were looking to add teachers as part of their team, and was lucky enough to become a member of the Mathagon team about 11 months ago, and I've been doing some content work for them and some work on Polypad. We're a really small group. It's, you know, when I first went to the website, I thought there was a big machine behind it. There's the founder and the CEO. His name is Philip. He does all the engineering and coding. I'm the head of content. We got a couple writers, a couple coders, and that's about it. So it's a small group doing a lot, and we're excited to share this math with the world. It is free for all users. It is translated into a number of languages. One is not Afrikaans, so if anyone out there wants to take on the task of translating it, I'm sure Philip would be happy to have another language to the menu here. So there are lots of things on Mathagon. We're going to spend most of the time on Polypad, which has a whole host of things where we're adding new features every day. I'm going to run through a number of examples. I'm going to show you what you can do as a teacher with classes. And so I'm just going to get started. So first at the top here, I'm going to click on Polypad, and that's just going to give me a new blank canvas. And so you can see on the left here, there are all sorts of tools: geometry, numbers, fractions, algebra, probability, and a question builder. I'm going to do some activities with all of these. I just want to start with a geometry tool. If I click on a square, that square gets put on the canvas. This is in Mathagon Polypad. We call this a canvas. So I have a blank canvas. I'm going to zoom in a little bit. And then I'm going to take a triangle and put it on the canvas. And it kind of snaps together. All right, I'm going to put my triangle right here. I can rotate it. As it gets closer, it snaps in place. I'll put another square and rotate it. I'll put another triangle out and rotate it. And then I can click and drag to do like a select all. I can move it around the screen. I'm going to copy it down here at the bottom and rotate it around. Oop, there we go. And put this right here. So it matches up. I'm going to copy one more and try to complete the shape here and put that in place. I got to rotate a little bit more. There we go. And I've made a hexagon in the middle, so I can take this hexagon and put it into place. So that shape provides me joy. I'm going to copy a bunch of them and try to make, oh, I took my finger off the shift key. So let me try again. I'm doing the multi-select by holding down the shift key as I do this. I'm going to copy, move this over here, beginning to make a tessellation. And then I could highlight the whole thing, rotate it like this. I can click and drag to just get the top piece. And then I'm off and running with a shape that is a tessellation. So I've done this with my 6th and 7th graders. They've had a good time exploring what shapes can tessellate. How do you know what the angle in the middle needs to be? And they've come up with all sorts of wonderful designs on tessellations. Let me show you one other example here. I'm going to go to library and do a new polypad just to clear the screen. So all of these polygons are fixed polygons, meaning I can spin it, I can move it, I can change the color of it, but I can't change the size of it, except for the polygon here with the white vertices. If I drag that onto the canvas, I can move a vertex around to make it a different size shape. Right now it's a pentagon. If I click on a side length, it'll add a vertex. So now there's a hexagon. I'm adding vertices as I go. If I want to remove a vertex, I can click on that and it will remove the vertex. So let me just show you one example here. I'm going to make it a 4-sided shape, a quadrilateral. So I'm going to click on a point to get rid of it. And I'm going to make this quadrilateral. I don't know, I'm just playing around here. So there's a quadrilateral. This is a custom polygon. I've designed it as I like. I want to lock it in place now so I don't mess it up by mistake. So there's a lock option down at the bottom. I'm going to click lock, and now it's fixed. I can spin it, I can change the color, but I can't change the size. So I'm going to copy this using the same feature down here. I'm going to change the color. I'm going to spin it around and put it on top. And then you may know that any quadrilateral can tessellate. Tessellate is I can fill up the plane with this shape. So there's 2 of them. My students have had a great time doing this as these kind of snap into place. I'll zoom out a little bit. Now I can highlight all 4 of them, copy, paste, and keep off and running and making my tessellation. I always say, is it going to fit? Is it going to fit? Oh, yes, it does, right? And as I zoom out and pan around the canvas, I have a great time making all sorts of designs with these. We could change colors. I'm doing a multi-select on all the purple ones. And if I make all the purple ones, you know, blue or something, I could make all sorts of great designs here. So that's fun. That is with the the custom polygon here. So that's an example of some things you can do with the polygons tool. I want to show you a lesson that I've done with my students who are beginning to think about area and perimeter of shapes. In the link document, I'm going to put this Google Doc in the chat again, because I know we just had some people join. So I just put that in the chat. In this document here that is coming up, the first link is to Pentomino's area and perimeter. So I'm going to click on that link, and a polypad is going to come up that I've done in my classes that I want to share with you. And this is an exploration of area and perimeter with pentominoes. And pentominoes, you may know, are all shapes that you can make with 5 squares. So this is my teacher version that I would want to share with my students. So you can see here, I've said this shape is made up of 2 non-overlapping pentominoes. And I used the line tool to make an outline of the shape. And so you can see this seems like I'm giving away the answer because it says the area is 10 and the perimeter is 14, but this is in my teacher account. So I'm going to make a class and I'm going to have students join my class as a teacher. So I'm in a teacher account now. I'm going to go to my teacher dashboard. I'm going to actually do it on a different tab so I can go back to that one. So I'm going to go to my teacher dashboard, and here's the class that I made for today. If you wanted to make a class, you would just go create new class, you'd give it a name, and so on. But this is the class for today, and you can see there's a class code. So if you have a Mathagon account and you want to join the class, great. If you have a student account, you can join the class. If you have a teacher Mathagon account, you can't join classes. No need to join the class today. I'm going to make an example student to show you what happens both on the teacher end and the student end. So my daughter has a Mathagon account. So I'm now in her Mathagon account. Her name is Emily. She's in 2nd grade. And I'm going to join this class with the class code. So I'm copying the code. Let me find where the other tab went. Here it is. I'm going to add a class code, paste it in, and now she's going to join this class. So you can see now on her account, her teacher and actually her parent, that's on both of those, is David Porras. That's me. So now on the teacher side of things, if I go, I'm going to just give myself a little room here. If I hit reload here, she should show up as a student. There she is, Emily Porras. So now I am going to go back to this Polypad that I've made where I want her to experience playing around with this. So I'm on Polypad, I'm going to go to class now. This only shows up in a teacher account. So I have a teacher account. So I'm going to go to class. I can choose my classes. I want to go to the Skoll class, and I'm going to assign this to her class. So I've assigned it. Now, of course, any link that I just wanted to share, right? Like here are all the links that I shared with you. I just copy and pasted them in a Google Doc. You can do that as well. But here I've shared this with her class. So now under the student side of things, if I go to Polypad on her account, so now I'm in my student account, and I go to library, you can see it shows up under assignments. So now as the student, I click on this, and these boxes are blanks, right? So on the teacher side of things, I put in the answers. She needs to figure it out. So here's a shape. She might look at this and she thinks, oh, the area of this is a 3 by 3 plus 1. That's 10. Great. Gives me a nice check. And the perimeter, 3, 6, 9, 10, 11, 12, 13, 14. Let's say she counts wrong and gets 15. Oh, that's not right. 13. Oh, that's not right. 14. Yay. And confetti comes down when you get them both right. I'll show you how to make those in a minute. And then she's on to exploring these on her own. Make your own shape using 2 pentominoes, record the area and perimeter. So maybe she takes this one, maybe she copies this one and brings it down here, and takes this one and copies it and brings it down here. And she makes that shape. And she could take a text box and enter the area is whatever. She could figure out the area. I think that's also 10. And then she could figure out the perimeter. I would certainly be doing this much slower in class, so kids could understand how to find the perimeter of that shape. You could use the drawing tool and put lines around it, as I did on the one above. If students found that helpful, they wanted to draw around it. and then move the shape out of the way, they could do that as well. So I'm just going to finish this one off, and then I could move these two out of the way, and that might be more helpful for her to think about the area in the perimeter. And so this was a fun activity where kids tried to find the biggest perimeter using two shapes, the smallest, could they find all of them in between? And then when students save their work, so she just saved it. Now, if I go back to my teacher account and hit reload here, hers is going to come up. So I could click on hers and I could share that with the class. So I could say, oh, class, here's one that was made by Emily. Emily, explain to us what you did. As I do this in class, there's about 20 student copies here. And if I want to share some without students' names, you can toggle back and forth between sharing student names or not. So I think that's a great feature to be able to assign them right to a student canvas and then share them in the classroom. The other thing to show you is there's a pentomino zoo where it's a fun activity for students. I've assigned this to kids. They work on it from time to time when they have an extra few minutes or something they want to do. Each of these animals is made up of all 12 of the pentominos. So what I encourage them to do is copy and paste it and pick an animal that they want. And all of these can be used to make the giraffe. You can flip them as needed. All right, so I could take this one and flip it using the flip button and so on. And so students have saved that into their account and then have had a good time playing around with that. So those are some of the geometry tools. I'm going to go back to the dashboard. So I'm just going to go back to Polypad here. I'm back in my teacher account. And I want to show you some of the number tools. So in geometry, there's lots of tools I don't have time to talk about. There's tangrams and the magic egg, which is a version of tangrams. We looked at pentominos. There's tetrominos. There's a ruler and a protractor, Penrose tiles and nature tiles. You can make all sorts of fun tessellations. Column tiles, my students have had fun playing around with. Fractals and tantric tiles. But I want to jump to the number tiles and share with you some ideas. I've used these to help students think about factors of numbers. So these number tiles, there's a 10 block. I can click on the 1 block and the 100 block, and I can move them around and spin them and rotate them. Here's a 10 block. If I split it, it makes them into 10 individual blocks. And so this 100 block, I could split, and it's 100 individual blocks. But I want to start fresh here. So I'm going to build the number 36. So I'm just going to click 10, 20, 30, 1, 2, 3, 4, 5, 6. And what's great about that, if I highlight all of those, there's a merge option down at the bottom. So when I merge those tiles, I get this group of 36. And this black tab, if I click and drag this black tab, it forms that group of 36 into rectangular arrays of the numbers. So you can see as I'm doing this, I'm thinking about the factor pairs of 36, right? It's 2 times 18, 3 times 12, 4 times 9. Oh, there's a square. We certainly know what that means. And so all sorts of wonderful activities that you can do just with these rectangular arrays of numbers to get students to think deeply about factor pairs of numbers, right? What happens when you have a number like 13, or that's 11 actually, right? There's 11. Can we make a rectangular array with 11? We know we can't, right? So that's a prime number, right? If I do 36 and try to divide 36 by 5, I can see there's 1 left over. So that these rectangular arrays even show the remainder when you divide by numbers. So all sorts of wonderful things with number tiles. You also may have seen these prime factor circles. If you've seen the board game Prime Climb, these prime factor circles are numbers split up into their prime factorization. So I just clicked on the number 18. I'll just zoom in a little bit. This is one of my favorite tools with 6th and 7th graders. I can pull the 18 into a 2 and see when I pull out the 2, it becomes a 9 and a 9. And now I pull out a green one, which is a 3. So there's the prime factorization of 18, right? What I sometimes like to do is keep 18 on the screen so you can see that it's 2 times 3 times 3. I can put them back together and it comes back to equal the number 18, right? Here's the number 19, can't pull it apart at all because we know that 19 is prime. And any number that you want, you can type in. So I type in the number 27 and put it on the screen, and we can see that that's 3 times 3 times 3. I had a good time with students thinking about the number 2021. I asked them first, do you think it's prime or composite? Just their gut reaction. And we can see that when we pull it out here, it's 2 prime numbers. And in fact, we can pull it apart and see that it's 43 times 47. So 2021 was kind of in the news a lot in January. It's the product of 2 consecutive prime numbers. And we talked in class about when's the last time that happened. So I put 41 on the canvas and we saw that, oh, the last time was 1763. And I'm old, but not that old, right? And then we asked when the next time that's going to happen. And certainly a couple of my students thought it was 49 was the next prime number. So we put that on and they were like, oh no, that's 7 times 7, it's not 49. And of course, some students thought it was 51. And then they were like, oh yeah, that's 17 times 3. So they knew that wasn't prime. So eventually we got to 53. And we saw the next year that it's going to be the product of 2 primes next to each other is 2491. So that's super fun. I've done this a lot to look at greatest common factors of numbers. So if I take out 18 and 30, right, this has been really helpful for students to think about what factors these numbers have in common. So they see that I'm going to copy both of these so I keep the numbers on the screen. So I think this visual for students really helps them connect the concrete to the abstract. So here they can see, oh, they both have a 2. So 2 times 9 is 18 and 2 times 15 is 30, but I can also pull out a green. Doo-doo, doo-doo-doo. And so there is the greatest amount I could pull out is 6 times 3 and 6 times 5, right? What I think is one of the most powerful tools I'm excited about as a teacher is providing students with the ability to use manipulatives when they need to. And if it helps them take these numbers and pull it apart, great. If they can abstract the ideas in their head and don't need the tools, awesome. So for example, I gave students an assignment where I wanted them to find the greatest common factor of a bunch of numbers. So I'm just going to build one here, 216 and 252, right? And most of my students, if I just wrote out the numbers 216 and 252, they would not know what the greatest common factor is. If I gave them 18 and 30, they could probably do that in their head. But it's at the point now where if I give students this question on a piece of paper, they come to Polypad because they know that the quickest way for them to find the greatest common factor is to do this. They're looking at the prime factorization, they're pulling this out, and they're saying, oh, there's an 8 and a 3. Oh, and here I pulled out 1 too many 2s over here, right? They only have 2 2s in common. I got to put this one back in. So the most they have in common is 12, right? So the greatest common factor. Oh, there's another green one I can pull in, right? See how great that is? The greatest common factor is 36. And what I think is great about this, I've made a number of worksheets where I put a text box here. So this is the question builder feature. So, you know, I might make a worksheet where I say, I'm going to add some text here. Oh, I just want to, yep. Find the greatest common factor. And so there it is, 216 and 252. I would go to my library. I'd save this. I'll save this as GCF. Save. And then I can assign it to the class. There we go. It's assigned to the class. I have to put in the answer here. I haven't put in the answer yet. What was the answer? 36 maybe? I forget what the answer was. I'm going to do it again. Right, and then this one had 18 was the answer, yeah. Oh. Did they have any more in common? No. Oh yeah, here we go. Is that the greatest common factor? It's not. There we go, 12 is the greatest common factor, right? So here, let me put in 12 as the answer. I'm overthinking myself here. There we go, now I've saved it. It's assigned to the class. I go to my daughter's account, hit refresh, and there it is, greatest common factor. So what I really like is if there was an answer like 18 and 30, a student might not need to pull them apart. But now a student on this one might say, all right, it's 2 oranges. I'm going to do it right this time. 2 oranges and 2 greens. I messed up the other one too, didn't I? The answer is 36, right? It's early in the morning here in the States. So she would put in 36. It's going to say it's wrong because one, that's 26, but I said that it was wrong. And she'd say, Mr. Porras, you got it wrong. All right, so I messed that one up, but I think you get what I'm doing here. I could fix it here and say 36 and then save it. And then if I refresh this, reload, yep. And now she would get it right, yay. All right, so great power in the prime factor circles, even though I was doing too many things at once and kept making mistakes, but hopefully you were able to follow that. The other thing that I want to show you here is I've made a lot of videos that don't have mistakes in them. If you go to mathagon.org/teachers, there are a number of videos and there's a whole series on how I use those prime factor circles to find factors of 180. So there's 3 ways that I use those tools to explore finding factors of 180. So if that's a topic that you teach in school, I would encourage you to go check those out. All right. One thing that we just added under numbers is these number cards, which are just really a card that has a number on it. You can enter any number you want, right? So 10 and 37, you put them together, it adds them together, not as dynamic as the prime factor circles, but some cool things to do with number cards. There's number bars, the rods for really elementary students. There are number lines you can put on the screen. There's multiplication grid. And then I'm going to keep going here because I have other things that I want to show you. I'm going to talk till 8:45 and then I'll open it up to any questions. There are some fraction things that I want to share with you. So there's a game called Cover Up. It is maybe 4th, 5th grade game, but it's a good, I've done this with my 6th graders. I used a number of the fraction bars and put those on the screen. The goal is to take turns. This is kind of a 2-player game, and you're trying to be the one that covers up the number 1. So I might spin this, and I got a 1/2. So I would put the 1/2 on top of it. Then it would be my partner's turn. They would spin it. Oh, they got a 1/2, so they win. They covered it up, right? That was the quickest game possible, and then we could play again, right? And that looks like a 1/4, so I got a 1/4, and then I could spin it again and see what my partner gets, also a 1/4, and keep going. And as you play more, students begin to think about what do they want on their move, what fractions left. So I think that's a fun introductory fraction activity for kids in middle school. What I did with my students to share with you on fraction addition, I want to share this Polypad with you. I was doing the question with them 3/4 plus 5/6. So I'm now using the pen tool to write in 3/4 plus 5/6. And I first, before students gave me any answer, I took the fractions and I took 3/4 and put it on the number line. And you can use the tab here to make as many fourths as you want. So there's 3/4. And then I took 5/6. I could also split them into individual pieces if you want to do that. So I can do that way to get 5/6. And I asked them for an estimate of this answer. So I have my number line between 1 and 2, and most students on their piece of paper and then shared with the class that their estimate was about 1.5. And I really made a big deal of that. They all said, great, that's a good estimate. And I said, awesome, wonderful. Is there any way the answer could be 8/10? And they all agreed that that was really silly. There's no way the answer could be 8/10. And I really emphasized that point, right? If we just add the 3 and the 5 and the 4 and the 6, there's no way that can be the right answer. And they all agreed that there's no way the answer could be 8/10. I wrote that on the board, circled it to try to really avoid that common mistake, right? And then what I think is great here, which is different. There's lots of tools online that have fraction bars, right? What I think is really powerful here, if you click on the number line, in real time, you can change how many divisions there are in between the number line. So I first made 2 divisions. And we now saw, I'm going to zoom in here. We now saw that it's more than 1.5. So our initial estimate of 1.5 should be more than 1.5. So I asked students to adjust their estimate, and they came up with a more precise estimate. And then I changed it to thirds. The announcements around in my school, sorry for the background noise. And that wasn't it. And then fourths. And then I asked them in pairs to talk about what might be a good number to split the number line up into. And they talked about that in pairs. But I did 6, that wasn't it. Then I got to sevenths, and a lot of students got really excited and confused because they thought sevenths would work. But we can see it's a little bit above the sevenths. But I paused there, and I put sevenths on the number line. And we talked about how it's 1, 2, that this answer should be pretty close to 1 4/7, right? It's not exact, but that's a pretty good estimate actually, 1 4/7. And then they all really quickly wanted me to jump to 12, but I made them wait. I did 8, I did 9, I did 10, I did 11, and I did 12. And then to really emphasize the idea, I took the 12ths and we saw that 3/4 was 9/12. So on my pen tool, right, I changed this to 9/12. I did it much neater than I'm doing now. And then I took the 12ths and brought it over here and saw how many 12ths that was. And then we wrote it as an improper fraction. And then I put the 1 on top, and we saw the answer was 1 7/12. Right? So I thought that was a really nice visual for adding fractions. Right? The next thing I want to show you, we did a fraction multiplication example. I'm going to go to a new Polypad. I'm going to go through this one pretty quick because I want to get to some other ideas. So I'm not going to do the whole thing, but we did 2 1/4 times 3 1/3. Right? And so now I used the fraction circles to do groups of 2 1/4. So it was 1, 2, 2 1/4. And then we did 3 1/3 groups of 2 1/4. And great conversation came as to how can we split these wholes into thirds, right? And how can we take that fourth and split into thirds? And so we had the 12th fraction bar out here to split that into thirds. Some people split these into thirds. We had students wanted to split the whole thing into fourths. So all sorts of great ideas, which I can come back to and show you more examples of that if we want, but I want to keep going. There's so much wonderful stuff. So I'm going to keep moving along here. One of my favorite things on Polypad is the probability tools and how easy it is to create all sorts of probability events for students to engage with. So there's dice. You can put a dice on the screen and spin it. You can put a coin on the screen and flip it. You can put a uniform spinner on the screen, and as you drag this black circle, it makes more and more sections, and then you can spin that. And then there's a custom spinner where you can change the size of the regions, right? And if you click on the circle, it can add a region. And if you click on a point, it'll get rid of the region. And you could go to geometry tool and go to utensils and stick the protractor on and measure the size of the angles of the regions if you want students to explore with that a little bit. And then you could spin it. But what I've done a lot of in school is think about rolling 2 dice, right? That's a common idea in middle school, right? What are all the ways to roll 2 dice and you make the tree? But what I think is so powerful here is the ability to make multiple sets of 2 dice on the screen really quickly. So in a matter of seconds, I'm going to make all sorts of pairs of 2 dice. I'm going to try to get to 50. So there's 5. Oh, I missed it. 10. 20. 30. 40. I'm just using the copy tool down here and the arrows on my keyboard to make this. So there's 50 pairs of 2 dice. And certainly I could save this for students and share it. Students have to do it, don't have to do it on their own. But now we can roll, actually, let me get to 100 dice, right? Here's 100 pairs of 2 dice, right? Let me just move them out of the way, zoom out a little bit. There's 100 pairs of 2 dice, and within a matter of seconds, and again, I could just share this with students, they can roll all 100 pairs of the 2 dice and maybe count how many double sixes they got, right? And if I have a group of 20 kids and 20 kids roll all 100 dice once, all of a sudden we have 2,000 trials, and we could make a prediction of how many double sixes we're going to get out of 2,000, and then actually go around and have every student share how many double sixes they got and add them all up. I think it's so powerful for kids to see that number actually happened. There are so many websites out there where it runs a simulation of rolling 2,000 dice, but it doesn't actually show you the 2,000 results. It just fills up a graph. And I think students don't really believe that the numbers that the graph are filling up are actually true because they're not seeing the dice being rolled. And so here to actually roll 2,000 dice, I think is really cool for students to see. Under library, all the way at the bottom are some saved example polypads. So there's one here that has 100 dice. And so one fun activity that I've heard about, I haven't done this in school because I don't teach exponential functions, but is every time I roll it, I'm going to delete all the 6s. So here I'm going to go through and I'm going to select all the 6s and delete all of those. I'm holding down the shift key as I do it and delete. I think I got them all. And then do it again. And without even introducing the idea of exponential decay, we're doing exponential functions here, right? Delete all the 6s. How many turns would it take to get rid of half of them? How many turns should we expect to get rid of a quarter of them? When would we expect to have no dice left on the screen, right? All sorts of great questions there. And just starting with 100 dice on the screen. I think that's pretty fun. I got 9 minutes. I want to show you some algebra tiles, then I'll open it up for questions. I know I'm going through things fast here, but this is being recorded, so you can go through and watch the video later. Algebra tiles. I've done a lot of adding positive and negative numbers with students. And so what's so great about these algebra tiles, there's one and negative one, and when you put them together, it makes a 0 pair, right? So just putting the negative one on top of the one, there's a 0 pair. X and negative x, you put those on top of each other, it makes a 0. And same with an x squared and a negative x squared. There's so many wonderful videos out there that don't use Polypad about how to use algebra tiles. So if you haven't used algebra tiles, go. There's a lot to learn, and there are features here that you can certainly do with the algebra tiles. But what I want to show you is an assignment that I gave my students, integer addition here, where again, it's this idea of students can use the tools if they need to. If they've already abstracted the ideas, they don't need to use the tools. I found in school, I've given kids the chips, the positive and negative chips, and they use them on their desk for a day or two, and then we put them away. And I say to kids, anytime you need the chips, go get them, if they actually want to see the negatives and positives. But kids never do, I think, because they see their classmates not using the manipulatives anymore, and they might feel embarrassed, or they don't want to show their classmates that they haven't abstracted the ideas yet. But if I assign this to a class, I'm going to go to my daughter's account now and reload. Here's the assignment. Now, in the comfort of her own home, she can decide, or students can decide, if they need to use the tiles here or not. She might know that -4 plus 9 is 5 and get that right. But when she gets to one like 12 plus -15, that might be harder for her to abstract those ideas. So she could take -15 here and drag it down. And she could take 12 and drag it down and see that, oh yeah, 12 of them cancel out. So there's -3 left. right? And maybe with 42 plus negative 16, maybe she actually needs to do that too. So here's 20. Oh, yeah, allow. Here's another 20. There's 40. She could build 2 more, right? She could actually do it. And what I think is really powerful about being able to make these worksheets and give them to students is it gives them like the freedom and safety to use manipulatives if they need to. If they don't need to, awesome. But the goal of manipulatives, right, is to build up the concrete ideas so you can get to the point where you don't need them anymore. I feel like in school, I've been guilty of rushing them to not using the tools anymore. But here I'm giving them the tools and I'm saying, anytime you want to use it, it's there for you. You don't need to go to a different spot of the classroom. You don't need to feel embarrassed about it. Just go use the tools. So I think these positive and negative tiles are great. Let me show you something that just came out this morning. In fact, we are adding things here all the time. So there's an algebra scale. Let me go to the balance scale. This is still in kind of beta mode. We have a lot of things that our goal is to add on this. I'm going to put on a weight, and I'm going to go to the number cards, and let's put on 7 on this side, and I don't know, let's go 30 on the other side. Now, it's not balanced yet because the default number for these weights is 1. So I put this on here. This is now 8 and 30, but I want this to be an unknown number. So I click on the scale, and if I click balance, it's going to assign the correct number to that unknown, so the scale becomes balanced, right? So I would make this as a teacher, then I would assign this to students. And what I think is really cool here is a student might want to put -7 on like one side of the equation. But if they go like this, it's not balanced anymore because we need, right? We got to put it on both sides of the equation. If they do something like this and think that's going to work, it's not balanced anymore, right? We know that's not going to balance it. What we need to do is put -7 on both sides of the equation. So now I can put the -7 on both sides. Oh, it kept balanced. And now if I combine these, there's a 0 pair. And if I combine these, I get 23. I like that the 0 stays there so students can actually see that they made a 0, and then that goes away. And now I've solved that as 23. Again, this is like brand new this morning, these negative number cards. So there's a lot that we're going to add about how to solve equations here that is coming soon. One more thing to show you, and then I'll open up to questions. Oh, actually, 2 more things. What I think is also great about Polypad is the ability to combine all the manipulatives on one canvas. Again, there's a lot of things out there that use algebra tiles, and there's a lot of things that use probability. But here's one quick example that I made of how you can kind of pull them all together. So I'm going to make a quadratic function with dice and spinner. And so I've made here the heads is positive. So the function that I just made here is, oh, there's a squared missing here. Sorry, x squared plus 3x plus the spinner was at 4. And then I would try to factor that. I would use the algebra tiles, right? So I'd go to my algebra tiles and I would say, all right, I have an x squared. I have a 3x. And I have a 4. Can I factor that, right? Is that factorable? And we know that it's not, right? Because the 4 is the 2 and the 2 and the 1 and the 3. And so I would want students to keep track of ones that they could factor and show the picture as to why they can't factor it, right? So here, I'll actually do it, right? We can put the x here, and we could do 1, and we can spin these around and get 2. Right, there's the 3x here, and there's no way to get those 4 in there, right? That's not going to work. So I'm 0 for 1, but I could spin these again and see if the next one I'm going to make is able to be factored. What did I get? X squared plus 2x plus 12. I could explore with that, right? And so on. So I think that's a fun tool. The last thing I want to show you is the following thing here, right? I did a visual pattern with my students, and I used a Polypad for it. And I just want to share with you the awesome conversation that came up. So these visual patterns are at visualpatterns.org. I'm sure you have seen these before. The goal is to find a rule that can predict how many tiles are in the 43rd pattern and the 1000th pattern, and eventually find a rule for n. So I had a lot of students talk about how they saw the shape as a rectangle here. And so as they were describing it, I changed the color of the rectangle. So they saw that this fourth figure was a 4x6 rectangle plus 2. And then we talked about that, in the next figures, and that was great. And then I had students who described they saw it as a square here plus this rectangle plus the 2. That was awesome. And so I did this on the screen as they were talking about it. And then there were students who talked about how they saw it as they put a square around the shape, right? And what I thought was great was as they were describing this, I was doing this in real time so they could actually see it. And normally in class, I would just be doing it on the board in marker, and I'd be making a mess of it, and kids couldn't really follow it. But here the student was like, now I had to subtract those out. Awesome. But my favorite moment where I actually saw the power of this tool, and this is the last thing I'll share, was the student who said the following: I never visualized the pattern this way. And when she started describing it, I had no idea what she was talking about. But she said the following. She said, see how there's that really long one? Can you kind of pretend it's not there? And I was like, what? And she said, pretend that long one's not there. So I said, all right, I can actually do better than that. So I grabbed the long one. I didn't know exactly what she was doing yet. She said, just pretend it's not there. And I said, well, no, I can actually move it out of the way. And she said, oh, cool. And then she said, pretend that one that's by itself, move it over. And I was like, again, I don't need to pretend, I can actually do it. And then she said, now that one that you moved down, can you like spin it and put it back up? And I was like, I sure can. So I rotated it and I moved it back up. And she was like, yeah, I saw this as like a square plus one left over. And all the kids in class were like, wow, that's so cool, right? And I think if she had been describing that without me being able to do it in the moment, that many of her classmates would not have understood what she was talking about. I'm not sure if I would have understood exactly what she was talking about, but to be able to use these tools in the moment and to share that with her, I found a really powerful example. There are so many other things on Mathagon that I have not even touched on. There are activities, there's a timeline, there are games, there are flashcards, and then there's courses, actually like units of study that are, a lot of them are for kind of grades 9 through 10. There's a lot here. Our middle school courses are really in development still. There's a lot more coming on the middle school courses that we haven't, that are coming out down the road. That was my rapid fire overview. I hope, especially for people that English is not their first language, that it was not too fast. I'm glad it's recorded. You can always feel free to reach out to me with any questions. I'm putting my email in the chat. On Twitter, I'm at David Porras. You can follow me on Twitter, ask me questions there. I got a few minutes. I don't know how long we had scheduled, whether I've gone over. If people have questions or not, whatever is best for the group, Johan, I will leave it to you.
Thanks, David. So it was really quick. That was one of the fastest 45 minutes of my life.
I'm sorry.
No, that's cool. So luckily we've recorded it, and I will send it to everyone so that they can revisit it. But I think what's really powerful, and that's something in our country that we haven't really explored yet, is the use of manipulatives in explaining ideas. And for the people who don't understand the word manipulatives, it is using something physical, maybe that represents, say for instance, an abstract idea. Like with the algebra tiles, you have the pink one, which is maybe representing negative numbers, and the blue one, which is positive numbers or whatever. We don't use that in our country, and that is it's actually sad. We have these tools, and we should use it to show the kids. Like we teach the kids, especially with fractions, that you should get the lowest common denominator. Why do we do that? And when you illustrate it, it makes perfect sense. So I think it's really powerful. So from my side, and I think I'm going to explore a lot. There is someone who said that she's willing to translate, so I'll put her in contact. That would be cool if we can have this in Afrikaans,
That would be great.
Especially for our kids. So that would be awesome. Just raise your hand if you have any questions that you want to ask David directly. Then maybe I'll unmute you, or you can just say in the chat, I have something that I want to ask, and I'll unmute you. Otherwise, you can just write in the chats. David, I just downloaded the mobile version, and I see it's not the same as the website, but it's still very cool.
Yeah, there's an update coming out at some point to the mobile version that'll match all the updates on the browser version. A lot of the canvases that I've made on the mobile version don't translate great, where it's a little bit harder to move things around. You can't do the zoom out and zoom in tool. So for a quick thing, it can be helpful on the mobile version, but to really engage in an activity, I think it's not ideal. And yeah, that power of a physical object to make sense of mathematics, I think is really powerful. And so that's where in the district that I work in, and in many schools in the States, our math education is having students engage with an actual tool to reach understanding of things. And these virtual tools, I think, are often better than the ones they can actually use in school to take that prime number and actually pull it apart into its prime factors. I think is like an amazing moment for kids, right? We do it in school, the prime factor trees, right? We'll take 24 and 2 times 12 and 2 times 6, and they don't, and I talk about how the prime numbers are the building blocks of numbers and how you can take them apart and put them together. And some kids, they got it and they're off and running. But for a lot of kids who struggle in math, as they've talked about prime factors as colors of things, oh, I totally messed it up, right? I had too much going on in my head when I was getting 36, right? But to say, oh, I see an orange and a green, and they both have that in common. Yeah, that's a 2 and a 3. Right, and you put those together to get a 6. It builds the understanding that then when students get to the point of just doing a process, they understand why that process works instead of just memorizing something that the teacher told them to memorize, right? And that's my goal as a teacher, is to get kids to like not just memorize something because I told you to, but like understand it so you own the learning, right? So you believe why we're doing that to find greatest common factor. And I think these tools can be really powerful for that.
Yeah. I'm a big advocate for playing, especially playing with math. And I think this is a great tool to play with math. And I think that our learners can sort of explore more, or should explore more, with the concrete stuff. And the virtual Polypad is a good replacement for the concrete stuff, especially because we don't have the resources. We don't have the resources to buy tiles for the whole class in the whole school, whatever, but we can have one PC with the stuff, especially in our country, in our context. So it doesn't seem like there's any questions. I think the questions will pop up when they look at the video again.
Great.
And then they'll just...
Yeah, I just put a link to a really quick survey. It's like 3 questions. You know, there's a commitment to have Mathagon be free to all users. That's gonna continue. I'm getting paid for Mathagon, like full disclosure, but it's free for everyone. And the goal is really just to like make it a great tool that is used around the world. I'm new to delivering these sessions to teachers. This is my 4th or 5th. I would love your honest feedback. As you know, as teachers, when people just say, great job, that's nice to hear, but not as helpful as actual feedback. So if there are things that you found about my presentation that could be better, I would really love to know. It's anonymous. Like, the more honest feedback, the better, right? That's how we get better. So please feel free to share any feedback.
So I'll definitely ask the teachers to fill in the feedback. And what was really cool is usually in a webinar or something like this, the number of participants as the session goes on decreases, but in your case, it actually increases.
Nice.
from 21 to 23.
Right.
Yeah, that's something. So thank you.
Yeah, my pleasure. It was great spending an hour with you. I'm sorry you had to listen to my voice for so long, but I enjoyed sharing these tools. You can give me a follow on Twitter at David Porras. I'm updating things on Mathagon, how I'm using it in my classroom, how other teachers are using it in their classroom. We'd love to see what you're doing in your classroom. If you have a cool idea, tag at mathagon.org. We are in the process of making a page on our website with examples from teachers around the world, how they're using Mathagon. So we'd love to feature some teachers from South Africa and how they're incorporating Mathagon into their practice. So feel free to connect with us on Twitter. I've learned so much as a teacher on Twitter. It is really an amazing resource. So
That's my space, definitely.
Yeah, great. All right, I have a class in 5 minutes coming in. So it is morning in the United States. Thank you for your time, everyone. It was great to spend an hour with you.
Thank you. Bye-bye.
Right,
Tot ziens. Julle lekker dag. Onthou julle sertifikaat kan kry en as julle vra het, stuur my net 'n e-pos.
Thanks very much. Bye-bye.
Bye-bye. Onthou ook om vir David daai vorm in te vul. Dankie julle. Tot ziens.